Hello, grade sevens. I hope that you are all doing well. I wanted to try teaching you a lesson using a video and downloading it to YouTube. My oldest son showed me how to do it, so I figured I would give it a try. So, before the break, we were talking about changes of state. So, if you take a look here, important to remember is that when something is in the solid phase, the particles are very, very close together. Their attractive forces are strong. And even though a solid doesn't look like it, the particles are moving slightly. They are vibrating. In the liquid phase, if you add heat, the particles are going to be further away from each other. They're going to have less attractive forces. They're going to be moving faster. And finally, in the gaseous state, the particles are going to be very far away from each other. They're moving a lot faster, and there's less attraction between the particles. Now, we also talked about this before the break. If you are looking at the changes of state between different substances, if something starts out as a solid and it melts, that would be called liquefaction. When you add heat to a liquid, you're going to move the particles faster, and eventually evaporation will occur, and then they will become a gas. Now, going from a solid to a liquid to a gas involves adding heat. If you go from a gas to a liquid to a solid, you would actually be removing heat. Now, due to the fact that we unfortunately can't get together due to the self-isolation, I was planning on doing a lab with you guys when we got back. However, we can't actually do the lab, but what I can do with you is we are going to do what we call a dry lab. Now, a dry lab is when I give you the data, and then you are going to create the observations, and you're going to answer conclusion questions. So the lab that we were going to be doing was we were going to be looking at what happens graphically when you add heat to ice. So in order to do this lab well, you need to know the following things. First of all, the temperature range for ice is going to be 0 degrees Celsius and below. So you can have ice that has negative values. Now, when something is boiling, as you can see in this picture here, and this is specifically water, then that's going to be roughly around 100 degrees Celsius. And when it's boiling, it's actually undergoing a change of state from a liquid to a gas. So in between these two, the phase that the ice would be in would be a liquid. Now, in the lab that we're going to be doing, sorry, one second. Okay, I've shared all of this with you guys on OneNote, so hopefully you are following along with that. So let me just go through the lab with you so you understand exactly what I want you to do. All right, so the purpose of this lab is we are going to be melting ice, adding heat consistently until it boils. The temperature, here's the data that you guys would have collected. So if you take a look here, we have time and we have temperature. So you're adding heat, and every minute you are looking at what the temperature would have been. So again, picture that, right? Oops. Picture that. Here's the ice in a beaker. Here's the thermometer. Remember those thermometers that I never wanted you guys to break? And so every minute you were adding heat, and you were just recording what was happening with the temperature. Now, what I want you to do with this data is I actually want you to create a graph. Now, there's a few things that's really important when you're making a graph. Number one, okay, you can either use your computer or you can use graph paper. I would highly recommend that you try using a computer program like Excel. It is a really good way to show data And, you know, it might be something that you want to do when you're showing your data for your Science Odyssey. So give it a try. You might as well give it a try. Or you can just do graph paper, and then that way, if you do that, you can just take a picture of your graph and send it to me that way as well. Either one's fine with me. All right, make sure your graph has a title. Okay, that's very important. The y-axis and the x-axis. So I'm assuming you guys know this, but I'm just going to recap it quickly. This is the y-axis. This is the x-axis. You want to put on the y-axis, you need to label it because this is physics, right? So you have to actually label what you're seeing. So temperature is going to go on the y-axis, and that is in degrees Celsius. And time is going to always be on the bottom, on the x-axis, and that is going to be in minutes. Now, that's really important to remember to put the units in as well. So what you're going to do now is you're just going to look at the data and you're going to plot the points. Now, I don't know if you've ever done this before, but because this is 0 and this is 0, right? 0 time and 0 degrees, you're actually going to be going down into the negatives for the first few points. And that's fine, all right? So just make sure when you're doing this and you're looking at the scale, right? Your lowest temperature is going to be -5, right? So your first point, for example, would be right here. Now, then you're going to continue plotting the points as you're going along. You're going to end up with a bunch of points. And what I want you to do is literally connect the dots after you've graphed all the data. Now, after you've done that, all right, you're going to answer these conclusion questions, and they're all based on the graph. The last question, you're going to have to actually go on the internet and do some research to find out what actually is happening in this lab, because it's not what you're going to see some unexpected results. So you need to try to be able to explain why that is happening. All right, so that's all I need to talk to you about today. I hope you're all doing well. Stay healthy, and we will touch base soon. Take care.